Okay, we're back with number 2 here. And I'm just reading this for the first time, so let's see how I do as a calculus AP student. It says a shaded region R, I see you down there, very nice, is bounded by these graphs, F and G. Okay, it says find the area of R. So for A, the area is simply the integral from 0 to 3 of this top function, which they're telling me is g of x, minus the bottom function, which is f of x, dx. And I just got to do that in Desmos, and I did not type these in first. So you got to watch me fumble along with Desmos. But that is okay. Oh, it's a separate window. Here we go. Come on over to here. Let me have this. This is all question 1 stuff. Let me close all this out here. Okay. Boom. So we need g of x to be x plus sine pi x. And we need f of x to be x squared minus 2x. Okay, and I definitely don't need this ridiculous window. I really just want to go from 0 to 3. So I'm going to set this up to look like what they have. So let's go from like -1 to like 3.5-ish. And it looks like y is going to go from -2 to about 4. There we go. So now when I do that, I should see about the same shape they have, which I do. And I just want to integrate this thing. So we need the integral from 0 to 3 of the top, which is g, minus the bottom, which is f, dx. And Desmos is going to be a pain in the butt and want parentheses here. And that's fine. It's 5.137. Okay. B. It says R is the base of solid. The solid at each x cross section, so perpendicular. So the bases look like this. They're perpendicular like that, which means we're dealing with a dx. Okay. It's a rectangle with a height x and base in the region. So I definitely heard about this question too. What that means is this red line here, which I'm going to call B, is the bottom of a rectangle. Okay, so this is this B there, that line. And the height of this rectangle is x. And it's really going to be like a really infinitely thin rectangular prism, which I'm drawing poorly here, but forgive me. It has a thickness of dx. That's what we're really doing here. So the volume of that shape is whatever B is, the base, times the height, which is just x, times its thickness, dx. And we need to add them all up from start to stop. So the only thing I need to know is, what is this base? Well, the base is clearly just this top to the bottom here, which is g minus f. So I'm not going to write B there. I'm really going to write... Let me give myself some more room. Come on now, Mr. Smith. It's really g of x minus f of x times x dx. And you need the x to be in the integral. You can't move it out front. Sometimes they say like the height of the rectangles is 2 or 3 or just a constant. Then you can move that out front here because that's a constant. We can't do that here because it's x. So I just need to evaluate this integral. And that's it. So let's hop back over to Desmos, which is here. And I can really just add an x in here. Is it going to like that? I'm not sure. I'm going to put parentheses around just in case. I think it was fine. Yep, 7.705 is what I hope you told the AP folk. 7.705. Is that what I just got? 7.705, yes. Okay. Part C, it says write but do not evaluate the integral expression for the volume of the solid generated when we're rotated about y equals -2. So down here, look, I'm just going to draw this shape again. We got G doing his little curly Q guy. It's going like this. Great. And then we got F coming in hot like this. Boom. And we're trying to rotate around the line y equals -2. That's down here. And every time we do a rotation, they're going to make circles. So our integral is going to be pi r squareds. Okay? And as I mentioned in class so very many times, actually we didn't spend a ton of time on this year, so I'm sorry about that, kids. But you take your pencil on the axis you're rotating about, and you draw perpendicular to that to the outside of this area. Okay, and you can do it a couple times, and you can see no matter where I do that, I'm hitting that top function. So big R in this particular case is the top of that, which is g of x minus -2. And because I hit it, when I was going to the outside, I hit the inside part like that. That means there must be a little r. But little r, like a pirate. What are you doing? Here we go. It is just that line. And again, I can draw that a couple different places, like here to here. But that is just going to be f of x minus -2, and I'd make that a +2. So that means this integral for part C, what they want is pi times the integral from start to stop. It starts over here at 0, it ends over here at 3. And they gave me that on this graph here. From 0 to 3 of big R squared minus the inner circles, which is little r squared dx. And since they just want me to write that out and not solve it, that's it. And then lastly, it says, D, it can be shown G prime equals this. Thank you for deriving it for me, AP. It says, find the value of x for 0 to 1, at which the line tangent to the graph of f is parallel to the line tangent to the graph of G. Okay. All that means, this is just a fancy way. Let's go back through this again. The x value where the line tangent to the graph of f, okay, is parallel. Well, parallel is talking about its slope. So that means f prime, that's the slope of that line, is parallel to the line tangent to G. Okay, well that just means I need f prime to equal G prime. So they gave me G prime, which is kind of funny because they didn't give me f prime. That's just a power rule. But we'll do that up here. So part D, I just need G prime of x to equal f prime of x in the window 0 to 1. So they're going to want me to find f prime because we didn't write that out yet. So f prime is 2x minus 2. It's not too bad. G prime they gave me. They didn't really need to do that. Y'all can derive this, right? I need to know where is this happening. 1 plus pi cosine pi x. So here we go. Let's grab Desmos again. I need to see u. I don't need to see all this junk. I need to see where do these two functions meet. And the way we solve this is we either graph one minus the other. So what's pi cosine? So we can move that 2x minus 2 to the other side and see where that hits 0. Let me show you what I'm doing here. I only care about 0 to 1 on x, and I only care about 0 on y. So I'm setting my window up like this. This is what I'm looking at here. And you can see that, so what I'm really doing here, you could easily also do this. You could graph cosine pi x, and you could graph 2x minus 2, and see where they intersect each other. Let's get rid of this blue. That's going to happen right here. That's what I need to happen. So 0.676. I think I saw somebody in the Calc AB Reddit mention that number, so that's good. So that's where they hit each other. Or you can move everything to one side and just see where this thing equals 0. You see what I did? So if I just graph this one and see where it hits 0, you can still see that it's that same number, 0.676. If you graph both of these and see where they intersect, you can see that it is 0.676. These are the same numbers. Okay? But either way, 0.676 is the number we want for this. And if you tell the College Board that x equals 0.676, if you tell them that, then you've answered this whole question. I think it can be shown. Find the value of x at which the line tangent to f is parallel to line tangent to G. That's it. So there you go. That's number 2. Get out of here, you.